All right, good. See, people are making it here. I was a little late because I had to run off and get my power. Close this so I can figure out how. All right. So we're here. This is 129S. Something is wrong with my projection. That's probably it. Yes, perhaps not. Aha. Okay. So now my projection is working. So we are here. It is May 6th. We're nearly at the end of the semester. So we'll just talk about how to attack others. Next week is the last class and then the final exam. And there are no more guest speakers. And there's only one more special event, which is the another purple team competition, but that's in San Jose, not here. Anybody's welcome, and it will be available online. Last time I did Sumo Logic, and I could not make it work, and nobody could make it work except Caitlin, so I complained online, and the Sumo Logic help team told me what to do, and it still doesn't work. So I'm a washout with Sumo Logic. But anyway, it is possible to make it work. Caitlin was able to make it work, and I suppose the Sumo Logic engineers can make it work. But anyway, all right, so let's just talk about attacking users. So, cross-site request forgery is one of the main attacks you use to attack other people on the internet. And in order to understand it, it's good to start with on-site request forgery. So this is session riding. This is where you take over someone else's session while they're logged in. There's an old version of this that Kevin Mitnick used in the 90s where you would predict sequence numbers and hijack a TCP session. And I see a chat comment coming in. Can anyone see the slides? Oh, yeah, is the thing not sharing? Let me take a look. Can't see the share, all right? Let me try to figure out what's going on there. New share, share. All right. Yeah, probably because I had to change the video. Is it working now? Thank you. Good. Thank you for telling me. Something like that is wrong. I appreciate you telling me because the weakness with my amateur projection system is I can't see what you see. Anyway, so the trick here is to trick the user's browser into making a request that they didn't really authorize. And this turns out to be pretty easy to do. So on-site request forgery is here at csrf.com. Let me go there. And csrf.com is slash there. Well, perhaps not. Should be there, but maybe it was wiped out in one of the many hacks I've had. I guess I'll just talk about it. Let me just see if there's anything on the homepage that links to it. Probably it didn't make it in all the backups and recoveries I had to do here. Looks like it didn't. All right. So anyway, here's the point where you sometimes have message boards that put up little pictures to decorate things. And it takes, question is the name of the picture here. So if you ask a question, it will pop up the question icon. And the point is, instead of just using a canned list of questions, it took a type from the user, which could be changed to something else. So you pass up something like type equals question, and the question is actually used as the name of an image. So if this is what's added to the page, source equals image question.gif, but the user controls the question. So in that case, you can put something in the type parameter in the URL, which is sort of like a path traversal attack, but rather than just going to a file, it makes a complete extra HTTP request, going to a PHP page and trying to do something like change a password. So if someone views the page from the link you create, it will perform an extra HTTP request inside the image tag, and that will attempt to perform an administrative act, and it will succeed if an administrator views your message. So that's on-site request forgery, because you did not take a script from one site and move it to another site. You took a script and added it to the site where it belonged, and it's still had an unexpected result. So anyway, to prevent this, it's the same thing in the whole class. If you can validate the input and take away all the tags that can lead to script execution, that would be one way to prevent it, but that is really quite difficult. You can filter out special characters, but even those are not always going to work because there are many, many ways to execute JavaScript, like on click and such. And cross-site request forgery is the more commonly referred to version of this, where you cause someone to send a request to a different page. So script on one site affects scripts on another site. You visit a blog and there's an image which causes you to make a request to Amazon. And the reason this works, you found it, how did you make it? It's not HTML. Yeah. Oh, good. Why, thank you. Let me bring it up here then. Good. All right, good. Good. Let's see if I can get anything to work. CSRF HTML. Ah, thank you. Good. So here you have it. You can put something here like question and submit it, and you'll see the image containing the question. But if you give it something else like question 2, it won't be able to show the image because it's literally putting the name that came from the user in that question tag. So here's the administrative action that goes in the question tag. And now it calls this new user call, result new user created. So that's all. It pops up a box. Good, thank you. All right, good. Anyway, so since people typically have multiple tags open and they stay logged into certain things all the time, like Facebook, then you can have a request from another tab go over and do something to their Facebook or their Amazon or anything else that people are logged into all the time. And that's cross-site request forgery. There is a thing called the same origin policy we talked about, where cookies from one site are only sent to requests from the same site. But CSRF requests still work. You just can't see the reply from the server. So you can't do multi-stage attacks involve visiting a series of sites, but you can often issue one command which takes effect. This is why things like Amazon's buy with one click are, of course, much more dangerous than a thing where you go to a shopping cart and confirm the purchase and such. All right, so here, for example, an administrator can make a new account with a thing down here where they go to something called new user step 2, and then they put in user role and password and so on. And if there's one request there, then that can be done for the cross-site request forgery attack. So if a request forms a privilege action, it requires only HTTP cookies to authenticate it, and the attacker can determine everything involved, then you can have a CSRF attack. So here's one where you trick the administrator into submitting that form, trick them into viewing that page, and it automatically submits this form. And here's a script that just automatically submits. Instead of having a button you click, it just automatically submits as soon as you load the page. There's many other ways to do it. You can also do it on load of the page and so on. So this happened to eBay in 2004. You could make an image tag that would cause someone to bid on something just by viewing the image. So anybody that viewed your product would try to buy it. So the main problem here is the cookies and the fact that cookies are automatically sent with every request. There have been many of these. Another similar one is the web interface DSL routers, and this one is in this book talking about default names and passwords, but the modern version of this is DNS rebinding because Internet of Things devices typically don't even require any password at all if you log in from home. So if I can use a cross-site request forgery attack to make the request come from your browser, it will take effect immediately. This is the wide open door of the Internet of Things devices. All right, so if you want to prevent these things, you'd have to have more than just the cookie required to identify someone, like a hidden field. If you had a hidden field in the real form, then they would have to send a request from your real form through your process, not by just tricking someone into sending a request from another page. That's the thing we've mentioned many times. Hidden fields are your best defense against a lot of these attacks. All right. There's also local brute force attacks. If you have a CSRF token that is not secure, people can guess it and eventually get in that way. All right. So cross-site scripting can also be prevented by these things. A simple cross-site scripting attack here where you try to go to a forum and go someplace the browser will send an Amazon cookie, but it won't know the hidden value of the hidden field, so it won't take effect. And that's, anti-CSRF and anti-XSS are quite similar activities. You just have to have some information that means they really came from your page. There's another related thing which Cloudflare uses to prevent denial of service attacks. A typical denial of service attack, you will send some HTTP request over and over and over and over. And what Cloudflare does is have JavaScript on the page that you must resolve in order to actually get sent to the real server. So if you're not an actual user viewing a page in a visible browser, but you're some kind of automated process, then you won't get past that. It's a similar issue. So, all right, you can sometimes defeat these things by using cross-site scripting to steal the token. That would be one way to do it, and it can work. All right, so I've got some cahoots about that. Let me bring them up. I should have a page full of them, and here we are. This is 13A1. All right. Yep. Dogs, cats. Okay, good.
I'm so gonna be an old cat lady when I get older. I'm gonna have like 3 cats.
It's good to have plans. Self-improvement plans, no less. All right, guess we've had enough time. People are there if they're coming. All right. So which one of these will present CSRF? All right, hidden fields, your best defense. Which attack requires a stored XSS file? Okay, that's on-site request forgery. You have the ability to inject scripts, so extra script is executed when people view the page. Which method of authentication causes this? Some cookies. All right, and what was the SAMI one? That was OSRF. We talked about it last time. People would view MySpace pages and it would add you to the MySpace friends, so it's still on the same site. All right, Mateo and WITB. I think we might have some record of who you are, but I might be good if you tell me your real name at some point. And all right. Anyway, the top first one and last one, I actually know who they are. All right. Here, best perhaps you tell me who WITB is. If I can figure out how to operate my computer. There we are. Okay, good. Thank you. Good. Well, I tried to put it where it would go. Wouldn't go over there. I'm not no luck trying to anonymize things. There. All right. Good. Thank you. Oh, here's more questions coming. Someone's asking, do we teach any summer courses? I teach them all over the place, but not at the college. Our department has just a couple. The CS department has a pretty good assortment of summer courses, but there are none from me at this college in the summer. Anyway, all right. So UI redress is another one that got a lot of attention. Now, let me see if I can make this go up. Nope, okay, all right, I gotta trick this thing to knocking it off. All right, now the thing is frozen up on me. Okay, I'm trying to get rid of that thing. Good, I made it. All right, so this is clickjacking, where you make a page look like one thing, and when you click on the things you can see, it actually goes to the things you cannot see. This comes from transparency and invisible objects. So here's a common one. You have something here, click on win big, but somehow invisibly, you've got other buttons. So when you click on the click to win, you're actually clicking on something else to do something you don't want to do, like give somebody else your money. So there's a lot of these. I've got one online, supposedly, UI.html. Let's see if that one works. UI. All right. So here's the good button, win an iPad. You win a free iPad. Here's the bad button, and you get hosed. Well, this one's showing up in front, so that's not very exciting. I think the point is there were some browsers. Oh, this one here is where you see it. And here's the harder choice, right, win an iPad and win an iPad. This one here has used iframes to absolutely locate these things and set one of them with an opacity of 0.1. So you can see the get hosed very dimly there. You click on win an iPad and you're actually getting hosed. And here's the impossible choice where the opacity is 0. So there is a get hosed button here, but it's completely invisible. And that's what you're actually clicking on when what you see is win an iPad. So it certainly does still work in Firefox. I think other browsers may have some defenses against these. Anyway, so that's one thing. You can also steal keystrokes. If you can trick people into typing in a line, you can take the keystrokes and have effect. That's another common one where they're filling in a CAPTCHA. You can even take those keystrokes and have them go into a JavaScript command or otherwise execute a script. You can steal mouse movements. If you get them to drag things around, you can trick them into dragging on the wrong thing. All these things are possible, and they work on cell phones too. So one attempt to prevent this was called frame busting. This was something a lot of sites implemented a few years ago. So you'd try to make it so that it would bust out of iframes. It would not let you put iframes on the page and run scripts on the host. But a Stanford study showed that almost all these frame busting defenses could be circumvented. So you could have this kind of thing here on a page which checks to see if the URL of the page matches the URL of the top frame. This is an attempt to guarantee that you don't have iframes referring to other pages inside the page. But what you can do is create an exception with this kind of code. And then you can hook the event so the event handler runs. So the actual protection is used to execute the attack. And this is like one we saw last time, I think, where the, it was in the news articles last week, where the anti-cross-site scripting defense inside modern browsers can be used to execute the code. This is frequently what happens because of the maddening complexity of scripts in browsers is the defense actually turns out to be another attack medium. So you can define a sandbox. This disables scripting, and the top level frame can use this to disable the script. So, you know, there's a lot of tricks to trick the browser into running the injected code, so these defenses are not very strong. This is very much like the misguided situation in browsers where browsers try to run bad code. And if they come across tags they don't understand, they just try to fix it or guess what should be there and keep going, which is the way the whole internet works, but it is just begging for exploitation and leads to an endless chain of attacks. So there's a special header to prevent this called the X-frame options header, which would make it so this page cannot be loaded in a frame. And that would seem to greatly help here. So they can't somehow build my page into some other framework and put some other writing on top of it. All right, mobile web pages often lack all these defenses, and mobile pages can be used. That I claim in your book, the mobile attacks are difficult on mobile devices. I have seen versions of these on mobile devices, but you can also trick people into seeing the mobile page on a normal computer and vice versa. All Right, now you can also, the cross-origin policy is supposed to stop cookies from going to the wrong domain, and it's supposed to stop scripts from running on the wrong domain, but there are ways to do it. Here's one way to capture it by injecting HTML. So if you can inject formatting HTML, but not script HTML here, before this form, then what you can do is inject this stuff where you inject part of an HTML page missing a quote, and this causes it to eat up some of the missing pages and create a mismatched set of quotes, which cause part of the page to be eaten up. We've seen this before. You can have a starting comment tag, a starting angle bracket, a starting quote, and that will cause some of the code that the developer wrote to be absorbed and vanish from the page. This is, again, the fundamental problem of having a page which is parsed, trying to match control characters like quotes, and then have a user being able to inject those special characters. All right, here's another one. You put in a form tag before the form tag. Now there are two form tags, which is a bad syntax. And again, if it was a proper computer language like C, it would just stop and say error, mismatched form tag, I refuse to run, but browsers will not. So they will guess and try to say what to do, and often the form tag you put in will override the next one. All right, if it blocks less than and greater than signs, you can still put text in the subject line of an email with a subject line like this, and now without a less than sign or a greater than sign, you have added CSS, and again, by putting in an unmatched curly brace, you're going to eat up some of the code the developer put there up to the first closing brace they have. And so again, you can remove part of the page and replace it by your page. So, all right, this ends up putting the entire response in the font family, including the anti-CSRF token. So this hidden value they were hoping to include is in fact absorbed by this and vanishes. All right. So you can host a page on your own domain, and when it tries to load the style script from another domain, it will load your malicious CSS. That's one way to do it. There's many ways to do it. All right. If you load JavaScript from another domain, this is extremely common in the modern frameworks. Kaz is trying to get me to make my pages pretty by using the modern frameworks that look pretty in browsers. And so the very first thing you do is put standard loading lines in the header that load a whole bunch of JavaScript from other pages, put it on your page. So this is commonly done, that you load a bunch of JavaScript from another domain and use it. This is how most people do it now in order to make their pages mobile and have it look good in both phones and in browsers. So this is a violation of the same origin policy, and it's very common. So the page will dynamically load script from some other server, and you get to inject code. So it makes this function call to show user info. This will appear to show one person's user. And so the attack, you make a page that loads the same script but defines a different user here. So to log in user, use this page, you steal their profile. There's a variety of these things out there. All right. So if you want to prevent these things, the same story, you have anti-CSRF tokens, things like hidden fields, so that you basically just have to make sure that if one of your scripts is running, it is running from a request that came from your page and not from somewhere else. You can try to poison JavaScript with bad code at the start. That's one possible way to go. And there are many other ways to do it. Yeah. Well, that's an infinite loop. This is the condition, like in C, it would be for I equals 0, I less than 10, I plus plus. But this has nothing changing ever, so it'll just run around forever doing nothing. Then if you put bad code at the start, yeah, well, I won't execute JavaScript after that, but actually I don't understand how you prevent it from executing the bad code you put in. It's a good question, and I don't remember. Prevent cost. Oh, then you load it with I see. You load it with XML HTTP request instead of script, and then you can remove the bad code. XML HTTP request is the modern way you do AJAX. Instead of just including a file in its entirety, you can do a specific request and get only part of it. So this would be the way to do it. This reminds me of an attack I saw a while ago where you would load part of a file. There is another advanced feature in HTTP. You can be downloading a file and you can discover I got like the first 4,000 bytes and then I'm missing 1,000 bytes. You can do a request that will ask for just from this byte to that byte of a file, just part of a file. And there were some attacks involving requesting parts of a file that don't add up right. Anyway, so this is a good point. With a more advanced request, you can request only the part of the page that's good, and the attacker won't know that. That's the idea. All right, you can also only allow code to be loaded via post requests. Then again, they couldn't use the normal include or other requests to get it in. They'd have to use XML HTTP request. You can't load it with script tags. This is rather like the HTTP only cookies. They cannot be stolen by JavaScript. Then there's Flash. I don't know if anybody cares about Flash anymore, but Flash also had cross-domain requests. And there was a thing called the Flash policy file. So this could only load from those sites and no others. And so that's the point. If you had a cross-site vulnerability, you could load a policy file from somewhere else and change the Flash policy and now get inside Flash pages. All right. All right, and that's the game here. Not posting a cross-domain.xml file won't prevent this, which is a belief people had. I don't think it's worth worrying about much anymore because I think Flash is pretty much over. Then there's Java. I don't know how much people are still using client-side Java. I think it's not quite as dead as Flash, but Java doesn't have any provision to handle this stuff at all. There were some serious attempts to beef up security of Java a couple of years ago. I think as the Java developers realized that client-side Java is pretty much dying, and they tried to convince people to use it anyway, and I don't think it worked very well. HTML5 has these advanced requests, though, for two-way interaction with servers. And you can add an origin header to cross-domain requests. And you can have another header, allow origin, which can include a list of accepted domains. So there are controls available to limit whether domains are allowed to load on a page, but I wouldn't be surprised if there are ways to get around that. Most of these defenses turn out to be pretty weak. Here's many other ways you've got access. You can limit the methods, you can limit the headers, you can allow certain headers, allow certain origin, and so on. One very simple problem with this is if your browser is old, it won't know any of these headers or obey any of them. And I'm sure there are a bunch of other problems too. Anyway, that's all I wanted to say about that. And I've got the hoots somewhere. Here they are. All right. We're very near the end. Are those cats? They don't look very much like cats. Little kitten faces, tiger faces, like Calvin and Hobbes' tiger. Okay. She did already. She already did that. That's over. Got extra credit by doing it too. All right. Well, let's charge ahead. All right. So a weak defense against clickjacking. That's frame busting. All right. How do you steal a token with HTML injection? All right. Adding a form tag. I was going to think JavaScript hijacking, but I must say these things kind of mush together in my head. Probably by this time in the semester, I may not be alone in that. All right. So the recommended way to stop clickjacking. That's the new one, the X-frame options tag. All right. What's the header field of browser adds to XML HTTP requests? It's the origin tag, like the referrer tag. It's in the request you send out. And which one of these controls flash security, if in case anybody cares? Flash is pretty dead. Not as dead as Silverlight, but it's pretty dead. I don't think Flash is coming back, but who knows?
That's as likely as Sam picking out EV6 again, right?
Which one is ClickCheck? That's the more formal term, UI redress, where you make a page look different. All right. I get the kittens, and all right. And then we got Warren Lee. All right. So I'm going to go upstairs and help anybody if they want to work on projects. Let me just take a look at the projects and see if there's anything I need to say about them. No, we're down here. We've seen these already, the SAML before, and MITM is the last one. All right.
You shrink the slides?
What's that?
You shrink the chapter 15 slides?
No, I didn't shrink them. What do you mean?
You should zip it. 15A and 15B.
Missing?
You should have 2 sets of slides.
There are 2 sets of slides, and they should both be up there.
Did you shrink them?
Did I shrink them?
Zip?
I don't know what you mean by shrinking them.
The 15B is a lot longer.
Oh, well, that could be. Yeah, that could be. Anyway, I'll do the 13B next time. That'll be the last one. Any other questions?
You didn't say you only test the 15A. 15B is like 80 pages.
Yes, it could be. Yes, we'll see. Next time. All right. Well, I'm going to stop this. I'll go upstairs. All right.